Physics, Part 99. In collision between bodies, application of the principle of conservation of momentum shows that the total momentum of system before the collision is equal to the total momentum after the collision. An elastic collision is one in which the total kinetic energy remains the same. In this situation, the relative speed of approach is equal to the relative speed of separation. An inelastic collision is one to which the total kinetic energy is not the same before and after the event. Although kinetic energy may or may not be conserved in a collision, momentum is always conserved. So is total energy. The impulse of a force F is the product of the force and the time delta for which it acts. Impulse is equal to force into delta t. The impulse of a force acting on a body is equal to the change of momentum of the body. The unit of impulse is Newton per second. There are a few section questions. Calculate the magnitude of the momentum of a car, mass 1.5 tons, 1.5 into 10 power raised to 3 kilogram, traveling at a speed of 22 meters per second. When a certain space rocket is taking off, the propellant gases are expelled at a rate 900 kilogram per second and speed 40 kilometer per second. Calculate the thrust on the rocket. An insect of mass 4.5 milligram flying with a speed of 0.12 meter per second encounters a spider's web which brings it to rest in 2.0 ms. Calculate the average force exerted by the insect on the web. Number 4, an atomic nucleus at rest emits an particle of mass 4u. The speed of the particle is found to be 5.6 into 10 power raised to 6 ms. Calculate the speed with which the daughter nucleus of mass 218u recoils. Number 5, a heavy particle of mass m1 moving with a speed u makes a head-on collision with the light particle of mass m2, which is initially at rest. The collision is perfectly elastic and m2 is very much less than m1. Describe the motion of the particle after the collision. A light body and a heavy body have the same momentum, which has the greater kinetic energy. There are some exam-style questions. Number 1, a bullet of mass 12 gram is fired horizontally from a gun with a velocity of 180 meter per second. If hits and becomes embedded in a block of wood of mass 2000 grams, which is freely suspended by long strings as shown in the figure. Calculate A, the magnitude of the momentum of the bullet just before it enters the block. Number 2, calculate the magnitude of the initial velocity of the block and the bullet after impact. Number 3, calculate the kinetic energy of the block and embedded bullet immediately after the impact. B, deduce the maximum height above the equilibrium position to which the block and the embedded bullet rise after the impact. Number 2, a nucleus of A of mass 222u is moving at a speed of 350 meter per second. While moving, it emits a particle of mass 4u. After the emission, it is determined that the daughter nucleus of mass 218u is moving with speed 300 meter per second. the original direction of the parent nucleus. Calculate the speed of a particle.